be joining us in a second. Otherwise, if you're watching the recording, hello as well. Today's Thursday, October 6th. This is our fourth class connect. So hopefully we're starting to kind of get into a routine and a kind of like a feel for what's going to happen. But what we're going to do, we're going to talk about Schoology. We're going to go kind of review what we talked about this week, go into some practice, and then we will talk about our class connect and let you on your way. So again, full day today. The 25 minutes always go by so fast. So yeah, I knew we'd be getting more people. That's good. Okay, welcome. I'm gonna start by going through Schoology. So let me share my screen and we will be on our way. All right, that's geometry. We don't need to go to geometry. Let's go to algebra. All right. Week 5, again, 5th week, quarters starting to wind down. I believe there's 9 weeks. So we are about at the halfway point. Unit 2, again, was a little bit different. We had a quiz, then we had a test. And then instead of having a real big test, I decided just to have a quiz on these last couple items. So again, 3 lessons, 7, 8, 9, IXL for some review, and then we've got our quiz. This is finishing up Unit 2. So again, submit your notes for some credit. Remember, there are lots of ways to do the notes. You can write them on a piece of paper. You can write them on your iPad. You can use the blank notes that I give you. If you don't like those, you can make your own. Again, I just want to see that you're writing things down, that you're following along during these videos so that I know that you are learning. It's helping you learn as a tool. So we kind of talked about absolute value, piecewise, and graphing inequalities. So let's take a look at some of those. So I'm gonna change how I share my screen and then we'll be off. So absolute values. And the definition of an absolute value is distance from 0, okay? So maybe we jot that down, absolute value. Distance from So the graph of it kind of works like this. So let's say that we have y equals the absolute value of x. So that means that when x is 1, y is 1. But when x is -1, -1 is still 1 unit away. When x is 2, y is 2. But when x is -2, it's still 2 units away. So it really kind of forms a V shape. So again, as we talk about parent functions, this is kind of what the parent function of a absolute value graph looks like. Now, we've done transformations before where we can slide it, we can reflect it, we can flip it. There are things that we can do to manipulate our equation. Now, it's kind of the same setup as this is our standard formula, okay? So y equals, and notice these h's and k's. So again, this is going to determine whether we slide left or right, and this is going to determine if we slide up or down. Now it's probably the tricky part, but it's consistent. The standard formula is x minus h. So if I took, let's say, x minus 2, that really means, because the standard is subtracting, that this means to the right 2 units. And again, I know that it's kind of confusing because usually you think negative, it's minus, I got to move left. So if we were to do one of those examples, let's say, I did a parenthesis instead of absolute value. There we go. Let's say that we did x minus -4, okay? Now this again would be subtracting a negative is really like adding. So I could rewrite this as x plus 4. But this shows you, hey, this is where that -4 comes in. So I got to move left 4 units. And then kind of similar right here, adding k. Oh, before I remember this, I think it's from last week. You had an assignment that was something like this. And it said translated. I can't remember what it was. Okay. All this means is, hey, if this is my if that's my thing and I want to say translate the function of x, but change it so that it's say x plus 3 minus 2. That means every single point, every single spot needs to go left 3 and down 2. So this would be 1, 2, 3, 1, 2. Okay, this would be 1, 2, 3, 1, 2. This would be 1, 2, 3, 1, 2. And then this one would be over here 1, 2, 3, 1, 2, right here. So again, to kind of review, all you have to do is apply these rules to every single point to translate that graph. So that was one, again, I think that was an assignment from last week. I saw a lot of people making that same mistake. So just follow your rules and move the entire function. We also talked about a piecewise function. So again, and this oftentimes happens when you get like a range of numbers. So it might be, hey, let's graph x plus 2 for when x is greater than or equal to 3. And then let's graph -1 when x is smaller than 3. So again, what would we do? We would draw our graph. We would say, okay, if I've got this graph, let's just mark it real quick. X plus 2 for when x is greater than 3. So I'm going to start at 3. And 3 plus 2 is 5. So let's see here. It'd be here. It'd be here. It'd be here. So this is going to be my graph going this way. And then I have to jump when x is less than 1 or x is less than 3. It's going to be all the way over here. This is a closed circle because it can equal it. So that line underneath means that it's equal to. We use a closed circle. This does not have the line, so we need to use an open circle, and it's just going to be at -1 throughout the whole thing. So piecewise is a way to graph things where I might have a certain graph for one value and then a different graph for another value. And honestly, that can happen a lot in real life where you say, hey, until this point, I'm not making any money. But once I get to here, then, each product is giving me more money. Or, hey, until this, like, we're only doing this until a certain point. And then once we get to this point, we're changing something. So piecewise they're kind of called step functions. And again, you can see how it's a step is maybe it's like, all right, I'm going here to here. And then I'm jumping up here to here. And then I'm jumping up here to here. And then I'm jumping up here to here. Again, using those open circles and those closed circles to kind of describe what is happening. And then the third lesson was about graphing inequalities. So let's just say, oh yeah, one more thing. Well, here, we can do this, but when you guys are filling out on assignments and stuff, please use the grid that's provided. So again, this was not a good example by Mr. Larson, but if you got this grid, you really need to use it. So I'm going to use these lines. That was not a very straight line. 1, 2, 3, 1, 2, 3. Okay, and then again, I've got these tick marks. Use the grid, okay? That will help you space it out and be consistent throughout working the problem. So let's say, for example, we have y is less than or equal to 2/3 minus 2. So first thing I'm going to do is graph this line. Now you really have to pay attention to your symbol. And does it have this line underneath? It does. So I'm going to use that. I'm going to say, all right, my y-intercept is -2. That's right here. And then I'm going to go rise over run up 2 over 3. Up 2 over 3. Now, because it's got this is going to be a solid line because it's got that equal to symbol, okay? When you're graphing things, please make sure that you graph at least 3 points, and you got to get, if there's any intercepts, if there's an X or a Y intercept, you have to graph that, okay? You got to get them both, and they got to be accurate. So this one's right here, this one's right here. Now, because it's an inequality, that means I have to shade. I got to determine what side of my line is it going to equal, okay? So this says y is less than 2/3 minus, we should put an x in here, 2/3 x minus 2. Well, what I should do, and this is my strategy, is if your line doesn't touch 0, 0, okay, if your line doesn't touch 0, 0, which ours does not, you should pick that as a point. So input 0 into your equation for x and input 0 into your equation for y. And as we solve it, we have to determine, is this a true statement? Is 0 less than or equal to -2? No, that's false. So this point right here, 0, 0, is not a solution, which means all of this stuff over here is. All of this area is an answer. So if I picked 5, -4, that would be true. If I picked x is 10, y is 1, that would be true. Okay. The other thing that we got to take note of is if we get not an equal to sign. So let's just say, okay, y is greater than, let's call it -3/4 plus 1. So again, I'm just going to start by graphing. My y-intercept is 1. My rise is -3. 1, 2, 3. My run is 4. 1, 2, 3, 4. So over here, and then if I go the other way, 1, 2, 3, 1, 2, 3, 4. Okay, so I'm going to go ahead and connect those. Now, this is what I wanted to note is that, let's move this. I'm just going to redo the whole thing. There we go. This is just a inequality sign, a greater than or a less than. So you have to use a dashed line. So we use a dashed line to show 1, 2, 3, 4 right here, that it's not equal to. So basically your answer cannot be on this line, okay? Your answer cannot be on this line. A solid line means yes, it can be. A dashed line means no, it cannot. And so because my line doesn't go through 0, 0, I'm going to choose that again. And I'm going to plug it in for y, plug it in for x, and see if we have a true statement. Is 0 greater than 1? No, that's false. So I need to shade the other side. Because it's not true, I need to shade the other side that does not include 0, 0. So this would be all of my solution. And so the final step is to be like, hey, if we had these two lines, where is our final solution going to be? And again, this would be okay for you to do, is just shade the overlapping area, which is right here. So again, what two parts do both of these lines shade and overlap? It's bounded by this line above and this line below, and it's into this equation or this area right here. So that's kind of a real quick recap of what we did throughout this week. Again, The shading part can get messy. That's why it's very important you stay organized. It's very important that you use units and you properly space your lines. It's very important that you pay attention to, do I have a dashed line or do I have a solid line? Because all of those things matter. Okay. I'm going to put a link in the chat. We're going to do some practice. Let me get it, see if I can get it pulled up here. My library, Algebra 2. I believe this was it. It's about word problems with absolute value. Perfect. All right, copied the link and I'm gonna post that in the chat. Now I get that graphing some of this stuff can be tricky, but I think that's where IXL does a great job with it. So again, if you need more practice, you can look at IXL. It does a really good job of providing that practice. I'm gonna turn that music off. Sweet. Okay, I see you guys are joining. Awesome. Once you click that link, get started. I'm gonna share my screen for anyone watching the recording. Again, my expectation is that you are pausing the video and trying it on your own. Get it to stop doing that. Pay attention to less than or equal to. Again, can your answer equal that? Can it not? Sometimes it can, sometimes it can't. That's why we have that line underneath to show if it equals to or not. All right, let's get a few more. Again, if you haven't clicked that link, please click that link. As far as and versus or, let me see. We'll talk about that in a second. All right, let's go about 30 more seconds. Finish up the question that you're on. Okay, let me see here. Let's pull up a question, talk about a few of them. So again, when we started this, we talked about absolute value. Oh, I do not like that noise. Every time I switch out of the screen, it starts the music again. Okay. So like absolute value, again, we got to think about it being on both sides of the equal sign so that it's either +8 and it could be -8. So that's where if we were to try to break it down and solve it, we'd have to anticipate this answer being on the right side being +8 and on the left side being -8. Otherwise, let's look down here. Again, what is the equation of the function in the graph? So we know it's an absolute value. Our parent function created a v. This is an upside down v, which tells me that it's been flipped, it's been reflected. So I know that I'm going to have some sort of negative sign here. So I can eliminate this answer and I can eliminate this answer because it's been flipped. So I need to have that negative. And then I see that it went 1, 2, 3 units to the right and 2 units down. So it's got to be a -2. So it's got to be a subtracting 2. And then we talked about how it's opposite. When it moves to the right, it's like subtracting 3. So I know because of the -3 and the -2 and this negative sign right here, that this is going to be the correct answer. All right, I believe that that is the Class Connect question. So let's take a look. Again, as I publish it. Remember, this is how you get credit. This is how you earn the points. So again, please do this. Even you that are in the meeting right now, you've got to do this. And this is the exact question. What is the equation of the function in this graph? It is negative absolute value x minus 3, subtract 2. All right, so as you finish up this unit, again, we're done with unit 2. Go ahead, submit your notes, take that quiz when you're ready, and then next week we're going to start a brand new unit. We got we're about halfway through the quarter, so keep that in mind. We will meet next week, same time, same place. Have a great rest of your day. Let me know if you have any questions, and I will see you next week.